How do you keep hackers out of your private data? Imagine your network is a secure building. A person approaches the entrance, hoping to get inside. To control this, you place a guard at the door. The guard performs an ID check to ensure everything is in order. You define specific rules for who gets in, based on their source address, their port, and their communication protocol. Because this person meets those requirements, they are allowed to enter the building. But what happens when someone malicious shows up? The hacker approaches the doorway, but they do not match your allowed rules. The guard denies them access and turns them away. By setting a default action of deny, you ensure that only verified traffic gets through. The firewall is your gatekeeper.
How can you send a secret? Imagine you have two computers, A and B, connected across a network. When you send a message like, "Hello," it travels openly. An eavesdropper watching the line can easily see your private data. To fix this, you use encryption. You turn your plain text into scrambled ciphertext using a key. When an eavesdropper tries to read your locked message, they fail because they lack the key. To share keys securely, computers perform a TLS handshake, which is like a digital greeting that establishes a private tunnel for your data. Once inside, your message reaches the destination safely. Laptop B uses its key to decrypt the ciphertext back into your original plaintext message. Data is safe in transit.
Why isn't a password enough? Imagine Alice trying to access the company database from her computer. Usually, she connects through the company network, as if she were in the office. To keep this data private, you use a VPN, which stands for Virtual Private Network, to create an encrypted tunnel that shields your traffic from outsiders. But once Alice is inside, what happens to that security? If her account is compromised, the trust evaporates instantly, leaving your system wide open. That is why we move to a zero-trust model, much like a high-security laboratory airlock. Before Alice can enter, she must present her keycard and pass a biometric scan to confirm her identity. Modern access works just like this equation. Access is granted based on your verified identity plus the health of your device. Identity confirms that you are truly who you say you are, while device health checks that your laptop is secure and free from viruses or threats. By combining these, you can move away from blind trust. Verify everything. Trust no one.